Okay, hey, this is Mr. Kestel. So this is the second part of your district packet talking about thermal energy. So we're going to be going over the uh, information covered in this part of the packet. Um, I want to say a couple things here before I get the video started. First of all, on this first page here, it's really hard to make the image and everything appear properly on Google Docs. So when you're doing this part of the assignment, you can just put a number next to the vocabulary word to be able to do that. The rest of it, you should be able to type in your information right on the paper that I put on Google Classroom. Also, throughout the video, I'm not going to go back and refer to this document, but all the information that you need to be able to answer all these questions will be covered in the video. Also, I will post the notes that I'm typing up on Google Classroom as well. Okay, so the topic for today is thermal energy, and we're going to be talking about a lot of different aspects of that and how it affects our lives. So let's start out with some definitions. I'm going to start with something that you are definitely familiar with, which is temperature. Temperature, we measure temperature in either Fahrenheit, Celsius, or Kelvin. In the United States, we mainly use Fahrenheit, but most of the world uses Celsius to measure temperature. And then scientists often will use Kelvin, but we're not going to get into exactly why. So temperature is the average kinetic energy of all particles in an object. So kinetic energy, if you remember, was the energy of motion. So what I have for us right here is a box with pretend gas particles in it, just to show us how the particles are moving and their energy. So this would also apply to solids and liquids. It just looks a little different. So two things I want to point out. I want you to pay attention to the temperature gauge here as we do a couple things. And I also want you to notice about how fast the particles are moving. So you can kind of see they're bouncing around all right. So down here I can change how much heat or cool. So let's go ahead and heat up the particles. And as the heat is there, you'll notice that the particles are bouncing around a lot faster. So and also the temperature went up. So as you increase the temperature, as the kinetic energy increases, the temperature increases. So let's include that. And so we can also do the opposite. We can cool the particles off. So as we cool the particles off, you'll notice that the particles are moving a lot slower. So the less kinetic energy, or the slower the particles are moving, the lower the temperature. So slower particles have less kinetic energy, less temperature. So so again, as the particles move slower, the temperature will decrease. If the particles move faster, the temperature increases. Okay, so what does temperature have to do with thermal energy? Well, thermal energy is the total energy of all the particles in a material. So to go back to our little box with some gas in it, the total energy of all these particles is what we call thermal energy. So if you add heat, then all the little particles are bouncing around faster, and so you have more thermal energy. So more temperature equals more thermal energy. Another thing to think about here with thermal energy, let's say you have a pot of water that's boiling, so we'll add some little bubbles here. Okay, and then a little drop of water comes out and splashes your hand as you're boiling some water. So both of these, all of the water here, the little drop of water and the pot of water, is at the same temperature. But, and I'm not going to try to write out same temperature with this, it's a little hard. But, so the pot of water and the drop of water are at the same temperature. But the drop of water is very small, but the pot of water is a lot bigger. So the drop of water has much less thermal energy, and the pot of water has more thermal energy. So that's why a little drop of water splashing on you, boiling water, it's going to hurt, but it's not going to do any lasting damage. But if you stuck your hand in a pot of boiling water, you're going to be in a lot of pain. You're going to really hurt your hand. Don't do that, because the pot of water has more thermal energy. There's more particles within that material. One last thing to notice is that thermal energy of an isolated system doesn't change. So in the example back here, if you notice, the temperature here is exactly the same. This box represents an isolated system, and so the temperature is not changing. But when I added heat or cold to the box, then the temperature changed. So isolated system means that the thermal energy, the amount of energy of it, is not going to change. Okay, next, we need to have a definition for the word heat, because it can mean, we use it to say a lot of different things. In science, heat is the thermal energy that's transferred from something with high temperature to something with low temperature. So heat always goes from something very hot or something hot to something cold. So when you feel if you pick up some snow to make a snowball and you can feel that cold, the snow is not transferring cold to your hand. What's happening is heat is leaving your hand into the snow. So heat transfers from something with high temperature to something with low temperature. Okay, have you ever noticed how some things heat up very quickly and some things do not heat up very quickly? For instance, something with, if you pop popcorn in a microwave, you can pick up the bag by the corners, but when you open the bag and the hot air comes out, you can't put your hand straight in because it's too hot. So that idea is something called specific heat, which is the amount of thermal energy it takes to change the temperature of a material. So the super specific definition is the energy to raise 1 kilogram of material 1 Kelvin. We're not going to get into exactly what we're not going to get into any more detail than that, but something with material with a high specific heat can absorb more thermal energy without a large change of temperature. And I'll give you a couple of examples here in a minute. Okay, next we're going to the study of this relationship with thermal energy and heat and how all those things interact is called thermodynamics. So this is just the study of the relationship between heat, thermal energy, and work. So big fancy word, but it's just a study of between heat, thermal energy, and how we can use that. So there's a couple different ways that thermal energy is transferred. There's a couple ways that heat occurs, so that we move heat around. The first type is called conduction. Hopefully you've heard of that. I'm sure you have. And this is the transfer of thermal energy by direct contact of particles. So, and by direct contact of particles through a material. So this is the idea. If you touch something hot, it's going to transfer heat to you. It's going to transfer thermal energy to you, and boom, your hand's going to hurt. It's going to burn you. So that's why we don't touch a hot stove, because conduction occurs. Conduction can occur in solids, liquids, or gases. So you can touch a hot pot, you could stick your hand in hot water, or you could hold your hand above the hot water where the hot gas is, the steam is. Conduction's going to occur. So there are a couple different types of materials that some materials are really good at transferring are really good at letting thermal energy pass through it, and some are not. So for instance, a hot pot, metal, is a good conductor. Conducts it well. So that we have a term for that, which I already said, is a conductor. So a conductor is material that allows thermal energy to easily pass. So examples of this would be metals like copper or silver or whatever. Okay? So conductors metals are usually what we think of conductors. They are metals. The other type of material is called an insulator. An insulator is something that does not allow thermal energy to pass through it easily. And I'm going to keep on trucking here and turn off my alarm because I do not want to have to pause it. Okay, so an insulator does not allow thermal energy to easily pass through. So examples of this would be like wood. Okay, wood is an insulator. Air is also an insulator. You can be in the same room as a boiling pot of water and you're not going to get burned as long as you keep yourself away from it. So conductor, metal, insulator, wood spoon, those are really good to cook with because the wood spoon's not going to get heated up. That's getting a little ahead. Let's see, I'm making sure I'm covering all of the things. So conduction, to kind of summarize this, conduction is helped by conductors and hindered by insulators. Really important thing here is you have to have some sort of matter to have conduction. Since conduction is a direct contact of particles, if you don't have any particles, you don't have any conduction. So that's the first type of thermal energy transfer. So the next type of energy transfer is called convection. And you probably have heard of this also. Convection is when thermal energy, so we'll say transfer of thermal energy by the movement of matter. So, and we typically, or well, usually this requires not only matter, but also fluid. Fluid is any material that can flow. So usually we think of liquids as fluids, but gases are also fluids because they can flow. When you fan your hand in front of your face, which I'm doing right now, but you can't see, you can feel the air moving toward your face, and that is a fluid. Sometimes solids can act like fluids, especially like deep down in the earth when different rocks and stuff move around, but we're not going to get into that. Anyway, so there are a couple different ways, types of ways that we use convection. One way is, one that we typically see is in a boiling pot of water. So in a pot of water, you see gas particles and hot liquid coming up, and then the cooler particles sink back down to the bottom. Hot things are less dense, cool things are more dense. So you get sort of a swirly action, and the next time you boil some water, you should be able to see that. So that idea is convection. Let's see if I have anything else I need to. So there's a couple different heating systems that use convection. So used in heating systems. Used in heating systems like forced, air, electric, and solar. Okay, so usually when you heat things up, you typically, most of the time, you're using some sort of convection. It's usually a lot safer than trying to put something very hot onto things. So and we'll talk a little bit more about convection heating systems here in a minute. So that's okay. So the last type of thermal energy transfer is called radiation. Now, radiation is when energy transfer. Oops, let me take this out of bold for italics. So, this is an thermal energy transfer that doesn't require matter. Doesn't require matter. What the heck is that talking about? Well, let me give you the perfect example. The sun radiates energy. It sends energy toward us, and most of that we think of as light, but it also heats us up. And that's why, in the summertime, when we have more hours of sunlight, it's warmer. And in the wintertime, we have less hours of sunlight, so it's colder. So that energy that's being transferred by the sun is called radiation. So hence radiation. Let's see. It is transferred. I'm doing terrible at spelling here. transferred by waves. So that's why these little waves here were there on this diagram. So light moves in waves. And so there's a lot of different types of waves and light waves. Heat is another word for that is infrared. So infrared waves are the part of the light that we get and feel as heat. I also told you that we think of light. Visible light is how we are able to see. And then, you've probably heard of UV waves. And so if you go out in the sun for a long time, you need to put on sunscreen. Otherwise, the UV waves can mess with your skin. UV stands for ultraviolet. The sun also radiates all of these different types, but we're mainly focused on infrared right now. Infrared, you've probably seen in movies and stuff like that. We can't actually see infrared, but the idea here is in this picture is that something warm, like this dude's face and his hands, are hotter, and the air around him and his clothes are a little bit cooler. And if you go online, you can see lots of different pictures and that sort of thing. So radiation is transferred by waves. Another name for that is called radiant energy. So the sun gets its own type of energy because it's so important. Let's see. Doesn't require matter. It's transferred by waves. And energy travels is okay. So that's radiation there for you. Okay, so in this picture, we can see all three types of thermal energy transfer. So if you got an electric stove here, there's heat being given off by the stove, and that can be radiation. It also is heating the air around the stove, so that's convection. Also, inside this pot of boiling water is convection going on. And then there's also some conduction. The heat is also being transferred into actually the side of the pot, but hopefully not too much into the handle, otherwise you wouldn't be able to pick up the pot. But there's definitely into the side of the pot. The side of the pot gets hot because of conduction. Gas stoves, well, we'll just say stoves in general, use conduction, convection, and radiation. Pretty sweet. Another type of heating system is called a solar heating system, which uses sun's radiant energy or radiation as a heat source. So there's two types of solar heating systems. You've got active, or we'll go passive first. Passive uses sun's heat to heat it to warm a house or a building. So I'm sure you've heard of the greenhouse effect. Well, the greenhouse is a glass building, usually for growing plants, that the sun's radiation goes in and then it can't get back out. If you've ever had gotten into a car or van or bus that's been sitting out in the sun a long time, then a lot of times sometimes it'll be very hot inside. That's because the sun's radiation got trapped inside. So we call that a passive because passive means you don't have to do anything. It can just sit there and it'll get hot. Um, so the other type is the opposite of that. It's called an active system, solar system. And this uses solar collectors to absorb, let's see if I can spell it right, absorb radiant energy from the sun. So a solar collector is different than a solar panel, but it's kind of similar. You put it out, it will heat up. The sun's energy heats it up, and we use it. Then we can use that to heat buildings and stuff like that. We don't really have those around in Cleveland because we don't get that much sunlight. We have lots of clouds. But places out in California, Arizona will sometimes have solar collectors for that, which are different than solar panels. Solar panels use the sun's energy to make electricity, not to transfer heat. So we'll add to transfer heat, something like that. Okay. Okay, so what's the point of talking about thermal energy? What do we do anything with this? So let's talk about that. So we'll call this the uses of thermal energy. So there's a couple different ways that we use it. First of all, your heating system. If you were in a building and it wasn't super cold this winter, then that had some sort of heating system. So heating systems usually use some sort of fuel or electricity as the source of thermal energy. So the reason your house or apartment or building or wherever you were at wasn't super cold was because thermal energy came from somewhere. So one example is a furnace, or some buildings will have what's called a boiler, but boiler is just a big furnace essentially. I'm kind of oversimplifying it, but so furnace uses natural gas generally to heat the air to make, and also heat water. This over here would be a water tank. So if you've ever taken a hot shower, that was heated by some sort of heating system. Also, an electric heater uses electricity to heat up air. So there's electricity going through the coils, and that heats the air around it. You get convection, and that gives you hot air. Same thing in a toaster. You got electricity passing through these wires, and that heats up the air around it and toasts your bread. That's also why you don't want to stick a fork or a piece of metal down into a toaster or a electric heater, because the electricity could pass into you instead of through the wire. And that is usually not good. Oops. Okay, a couple other examples. One example is called a heat pump. So a heat pump is some sort of device that transfers thermal energy from a cold area to a warm area. Okay, so wait, hold on. We said that energy goes from hot to cold. Well, sometimes we don't want that to happen. Examples are in a refrigerator or an air conditioner. These have heat pumps in them that pull heat out of an area and push it out somewhere else. So, for example, this air conditioner here pulls heat out of the inside of the building and pushes it outside of the building. So same thing in a refrigerator, will pull heat out of the air and pushes it away somewhere else. So if you like having a refrigerator or having an air conditioner, heat pump is super important. The next thing is a heat engine. So this converts thermal energy into mechanical energy. So, one example of that is an internal combustion engine. Okay? I'll add here as an example of a heat engine. So, internal combustion engines, these are the engines inside of a car, truck, bus. There's some sort of engine inside, and it's using heat and a transfer of that to move. It's a lot more complicated than just that, but inside the engine you have, like in this one, we have 4 of these things called pistons, which move up and down. So there's a little tiny explosion right here from using igniting gasoline, and that pushes the piston down, and then the piston moves back up. And so you can see like 2 of these pistons are pushed down, 2 of these pistons are pushed up. So the inside the internal combustion energy, we call that a stroke. So the stroke is the movement of a piston up or down. So one stroke is, I believe, going down and then back up. But I could be wrong on that, and somebody, I'm sure, will someday correct me. This is kind of a side view, so the piston goes down, and then it gets pushed back up. And there's a lot of complication. You can watch YouTube videos if you want to learn more. So that's a heat engine. Last, we have radiators, which are also used in cars. And these use convection to, well, I guess use convection and conduction to cool off fluid. So cool off fluid and cool off an engine. So I have a diagram of it. I don't think I'm explaining it terribly well, but so typically in an internal combustion engine, you have fluid that is comes out of the engine. This is not gasoline or oil, but this is a coolant, which will go in, and so the engine heats up the coolant, which will then go into the radiator. And the radiator has all of these little tiny metal bands, which the coolant passes through, and then you've got a fan which blows on that, and that will blow the heat away and cool off the fluid. So then the fluid comes back out and goes back into the engine. So that's how you keep your engine from overheating. I had personal experience of having a radiator fluid leak, and then my car overheated, and that was no good. So that is the last example I'm going to give of thermal energy and how we use thermal energy. So hopefully you found this helpful, and have a wonderful day full of laughter and joy.